Hey everybody, how are you doing? I hope you guys are having a great time. This is Brad Dyke, and as part of my pre-data center build process, I had a side project that I thought would be valuable, and I thought I would show you a really quick and easy, simple way to clone NVMe disks. Now, what I'm referring to really is the standard NVMe style or the PCI based driven cards. You have these interfaces that, I'm going to clone this from a 512, which is what this is, to a 2 terabyte footprint. Now, there are two ways to do this. So, what I decided to do is I need to build a station for this requirement. So, I pulled out a good old fashioned classic case design implementation. And with that design implementation, if you look inside, I have a pretty clean chassis environment in there. Very simple configuration. A Celeron baseline processor, 8 gigs of RAM. Yeah, that is a 1060, but it's a 6 gig, so it's not a mining card, not really. And then 120 gigabit SSD drive for the boot process. Now, also very important is I wanted to make sure that I had the slots I needed to do what I've got to do. So for my PCIe requirements, and I do. So what I'm doing is I am building this system, which is a baseline system in a classic case, so that you can see how you can take something that's old. If you recognize the front of this case, you'll see what I'm talking about. It is a genuine, true classic. And, it has all the basics in the subcomponents, but I've built it so it can be aerated fairly easy and make it a very easily manageable burn station for creating my NVMe burn cloning process. So with that, there is one other requirement you need to do, and that is you're looking in there and you can see these right here, one there and one there. Those are going to handle these cards. Now this is a PCIe NVMe slot card, and it basically is a 512 gig drive. And then this one is actually the same type of card, except it has a external SATA interface on it. And if you look there, it will show you the class right there. Autofocus. Yeah, there it is. Tells you the class of the interface, and you can place one card into there, and you can clone from either two PCIe cards side by side, which is where I have the room for, and or you can do a SATA from an NVMe PCIe bridge connection. And then with that, you can just choose your cloning software, whichever one you prefer. Specifically, I use PC integration style tools for my own use. And you can clone an operating environment right over. And then once you move it over, you can then go into the Windows or the Linux environments and expand out your smaller initial partition to fill into the more advanced partitions. Now, one other thing to note here also is you notice that you have anodized black heatsink and you have an open true copper sink. Now this does have a very small urethane coating on it that's temperature sensitive, but it's principally exposed copper, unlike this anodized aluminum, which is not. Now that means that this is not going to give you your heatsink functionality as well, and its ability to stay on is kind of complicated too. That's why they have these bands. But if you use it, go a little more expensive on the heat sinks, because that's the key denominator about NVMe and or any other variations of these kind of drive devices is heat is its enemy. That is something you must be careful with, because you just don't want these things to get too hot. If they do, they degrade, and that's not good, and hence now you got to go cloning. So I wanted to show you this real simple build. It is very simple, very simplistic in design. It's designed to be torn apart quickly and rebuilt. My old test bridge is now a mining rig, so that makes it a little difficult in there to be able to do more with that. But I am thinking about adding more memory to this unit just to give it a little bit more diagnostic state. And with the open free base slots that I have down there, I can put all types of diagnostic states into here and test things. Plus, not to mention, I've got lots of capacity here in regards to storing test drives and so on, and those formats. So, anyways, I thought that would be of some value to you, that you would get a good feel for how difficult is it to build a cloning station for VMN. Anyway, these guys right here. VMNE. I still can't talk today. But anyways, the point is, to build a station that's really simple, I only put $15 in each of these cards. I got a split card because I just wanted the extra capacity, and I have a straight card in case I need to do like direct diagnostics and stuff like that. But this is a really great solution. One other thing to consider also to have is to consider having what's called an external SSD style interface chassis. Now this one can do both eSATA and it can do USB right here. And the outboard on USB is not great. That's not a good way to do it. What I would recommend is you go the eSATA interface, because that allows you to run native drives in the environments. And with this particular guy right here, I can put SSD 2.5 inches in here as well, and that would allow me to be able to really get my setup done and have both SSD 2.5 inch cloning, and I can do NVMe NVMe style drive formatting and cloning as well. So this is going to be important to me down the road as I start doing some work. I really don't want to have to spend hours and hours and hours of extra work. I just want to hit these drives, do them, clone them 5 to 10 minutes, and I'm done. So with that being said, I hope this is able to give you some insights on how cheap and efficient it is to simply go in and build yourself a cloning station. All of this cost me roughly about $200, and that's with the extended eSATA interface included. So you don't need a fancy processor. You can recycle an old motherboard if you want. Most of the money is in, the stuff you recycle. So that does add up. So about $200 of old gear so that you can do what you want to do. So this is Brad Dyke signing off. I hope this helps you guys. Please keep enjoying what you're doing and have fun at the same time. I'll let you go. God bless.